So today we will start with the support. Okay, so for any structure, support is very important. Okay, without support, like the structure will be collapsed. Okay, so support, we can say we have a foundation. So foundation is a kind of fixed support. Okay, so now in this structure we don't have any supports. So for creating support, what you need to do, you have here page control. Okay, in this page control you need to go to general, and in this general you need to go to support, and where you can able to create a number of supports. Okay, by default it will be having no support. Okay, so here what we can do in the sense, like you can just click create option, and here you can able to see lots of supports available. So whatever you want, you can able to create and you can able to assign. Only these two steps we need. First you need to create and then we can go for assign. Okay, so first we will start with the fixed support. So support in the sense, it's a kind of restraints. Okay, so I will explain in the Excel sheet. So here we have some supports. So fixed in the sense, it can't able to support displacement load. Okay, and we have 6 degrees of freedom. 6 degrees of freedom in the sense, and can you able to see my whiteboard?
Yes.
Okay. So you have X, Y, Z, right? So Y is up, Z like this. And here you have, what are all the things? We can say here, we can say Fx. Okay, and here we can say Fy. Okay, and here we can say Fz. Okay, and apart from this, we also have moments.
Yes.
Okay, this mx, and then here you have my like that, and then we have mz like that. Okay, so this is what 6 degrees of freedom: fx, fy, fz, mx, my, mz. Okay, so now can you able to see my Excel sheet?
Yes, I can see.
Okay, here I will tell you fixed support in the sense it can't able to like move any of the x, y, z axis, and either it is not going to rotate in x, y, z. This is like a translational thing, and then this is like a rotational thing. So all the 6 degrees of freedom, it will be null in fixed support because it is fixed. It is not going to move anywhere. Okay.
Okay.
And then we also have enforced. See here in STAAD Pro we have enforced. When you click fixed, we can able to see all these 6 degrees of freedom. And even it is the same in the enforced. Then what is the difference? There is a difference. What it is? So what it was in the sense, like we can go for support displacement load. We can go for support displacement load in enforced kind of supports, but we can't able to go for that kind of support displacement load in fixed. So this where we are getting. So we can able to get that from a load. So that I will tell you when you are dealing with the loads and definition, or I will show you now. Loads and definition. Here we have load case details. You can able to add some load case. So this we will discuss later. Now I'm just going to add some loads.
Okay.
And later you can just go and add here some kind of load. When you are going for nodal load, you have support displacement. This is what it is. We can able to provide some value here in meters. Okay, this we can't able to do in fixed, but we can able to do in enforced. Okay, this is only the difference.
You mean the support can move?
Yeah, maybe you can put some value now. According to that value, it will move. In that case, you need to provide enforced kind of support. If you are giving fixed support and you are giving this kind of assignment, it won't take. Actually, it won't going to change anything in the structure. Okay. So that is what I mentioned in this Excel sheet. Enforced means we can go for support displacement load. Fixed means like we can't able to go for support displacement load. Okay, and it remains the same. All the 6 degrees of freedom will be nil in both of the cases. Okay, and then what you want, and then what you have in pinned support. So pinned support is something.
But if in enforced if there is a displacement, then how all the 6 degrees of freedom are arrested?
No. That is like negligible, right? Negligible, right? Like that you can able to provide, because sometimes in some cases, we can say the soil condition is not good. Based on the soil condition, maybe negligible settlement will be there, and you can put that kind of values in that. You understood, na? Some cases based on the soil conditions.
All right. Okay.
Okay, so pinned support in the sense like which will be having like restraint in XYZ in translational motion, but it is like a release in the MX, MY, MZ like rotational motion. So this is what the definition for pinned kind of support. Okay, it will be restrained in a translational motion and then it will be released in a rotational motion. That you can able to see in software support and create, and here you can able to go for pinned, and here like all FX, FY, FZ, it is like a restrained. Okay, there is no movement in that, but it is not restrained, it is released here in MX, MY, MZ. Okay,
Can we restrain it to MX and MY?
no, we can't. This is pinned support in the sense it can able to do all these three rotational, it is having all these three rotational freedom. Okay, then we also have fixed but. So fixed but in the sense now you are asking, na? So specifically if you want to make changes, you can go for. So for example, spring kind of supports we can create in fixed but. Okay, or we can say roller kind of supports we can able to create in fixed but. See, for example, if you're considering some roller support, so roller support, how it will be? Here I will draw the roller support. And it will be having like this. It's the kind of roller support. Okay. In this, it can able to move only in X direction. And it can also have a degree of freedom for MZ. So FX we need, and then MZ we need. This is for roller support. Okay. So that you need to release it. Okay, that's why I just having FX and MZ not striked out. Everything is striked out, which means if I am having the strike out in the sense, it is restrained. If it is not striked out in the sense, it is like released. So that we can just do in the software. See, here you have create. So here you have fixed but. So you can able to release whatever you want. In the roller support that we discussed, we need to release FX and MZ. Okay. When you are releasing, you can't able to define spring. If you want to define spring, you can just put the values here. So this option you have only in fixed but for spring kind of support.
Can you please explain what is spring?
Spring?
Yes.
1 minute. See, for example, spring support can act in two manner. One is compression, another is tension. Okay. See, here we also have multilinear spring. So here we can just go for displacement and then stiffness. Okay, this we can refer some code books or something, and then we can put some values here. Okay, and we also have tension and compression only springs. And here you can select the type, which type you want, tension spring or compression spring. And then in which direction you want that K factor. K factor in the sense it is only applicable for springs. Okay. So this support requires earlier. This support requires earlier assignment of the spring support. So once you do there only, we can able to do here. If you are not doing here, here we can't able to do anything. That's why they're putting in note.
Okay.
Okay, now one by one we will see what it is, and we will assign to the nodes. Okay, and we have anything left over here? Yeah, fixed but, enforced but also same, but no spring. If you don't want any spring, then you can go for enforced but.
Okay.
Okay, so in enforced but like we have everything FX, FYZ, MYX, MY, MZ. This you can select for roller support.
Okay, where we will use this? All the supports?
No, it depends.
What are their applications?
Yeah, it depends. Many, for example, here you have fixed, right? Fixed in the sense like we can say it's a kind of a footing. For mostly we will be using fixed support.
Okay.
And apart from that, if you have any steel structure where some gantry girder or something is moving, okay, it is moving now. So that kind of things, then we need to have some other supports. And even for trusses, the supports will vary. Okay.
Okay. So, sir, if suppose if there is a cantilever steel structure,
okay,
there is a pole,
okay,
and there is a main rafter,
okay,
which is making a L. Okay. And to support this L, there is a bracing connecting the rafter and the pole. So
in that
how
case,
it will
like
become?
we can go for pinned kind of supports, okay, that vary for different applications, and we need to study it before assigning, okay.
Yes.
Okay. First, we will see all this, something we can discuss. Okay. See here, we also have inclined. Okay, inclined in the sense, what are all the things we are doing here? This is for global XYZ, normal. Okay, not inclined one. And if you are going for inclined kind of access, then you can put that reference here, and you can have the same things. See, fixed, everything is closed, and then pinned.
Okay.
So it is similar to the same concept, and fixed but, so everything is released. Okay, enforced. Again, everything is closed, similar to fixed. And enforced but similar to fixed. But here we can't able to put a spring, define spring. But define spring only can able to do in fixed but. Okay, so all this is for inclined kind of members. Okay, then you can put the XYZ coordinates or reference joints, and you can select the joints from here. Okay, all this coming under create supports. Okay, and we also have foundation in the sense you can give some footing, length and width of the footing, but we have a special software like plugin STAAD foundation. So when you're going for STAAD foundation, then this is not needed. So we will just assign fixed supports, and we will directly go to the STAAD foundation. From the STAAD foundation, we can able to just do whatever we want. Okay, now you understood now all kind of supports. Okay, only
Yes.
the
Yes.
assignments it vary for different kind of structures. What we can do is like we can create one by one. First, we will create fixed supports. You need to add, only you need to add, and then you can select it. And here we have assign to selected nodes, assign to view, use cursor to assign to edit list. So all this four manner we can able to go for assignment. What I'm going to do means like I will start with selecting the nodes. See, I'm selecting the node and then assign to selected nodes, and you need to click assign. So you need to put yes. Then we have fixed support for these columns. Okay. Okay. Again, I will create another one. Another one, pinned support we will create. Okay. And then this is what the pinned support looks like. And then we can just go for selecting the particular nodes. So you need to hold control, otherwise it is going. Okay. Assign to selected nodes. Assign. So we have pinned support here.
Why you have used a pin to support here?
No, I'm just putting for example. Okay, so
Okay.
in real life it may vary, like pinned support in the sense like for only one beam in one direction, something like that. Okay, that based on the input software will analyze. Okay, but just I'm telling for example.
Okay.
Another, I'm just going for this fixed but. Okay, this is roller support. So roller support, I will just take these two release, and I'm just going to add. See, this is roller support. Now I'm just selecting these three, and then I will assign this. Okay, then you can able to see the roller support. This is what roller support looks like. Okay.
Okay.
The same way you can able to create any support, and we can able to assign it. Okay. If you don't want, you can delete it. If you want to edit, you can just edit it accordingly. You have edit option, and also you have delete option. When you are deleting, everything will be deleted, okay, from the structure.
Okay.
Or we can just go for no support, and we can assign also without deleting. Okay, so I will create one fixed support, and this is what you can just go to, and then select this, and then assign to selected nodes. Okay, if you want to remove and without deleting it, how you can do? You can just go for no support, and you can just go for assign to view, which means like overall where there is a support, it will become no support. Assign. See, this is what like the assign to view concept. And
But
use
the points for supports we need to select manually.
No, this is like all this the manner we can able to do. For example, use cursor to assign in the sense one by one we need to assign. See, I'm just
Can
going
you
to
assign
assign.
Can you assign to view?
See, like this, it is like a third option. Okay. And then here, like you need to have a nodal number, control shift N, right? Shift N, and then you can just go for support and go to edit list, click this. See here 19 to 21 we can put.
Okay.
19 to 21 assign. It is assigning, right? And then 1, 2, 3 assign. It is assigning. Okay, all these three you've seen. Assign to view in the sense like it will assign all the nodes, but support only for this base, open base. That's why we are putting open base. Assign to view in the sense, assign. It will assign to all the nodes. This is not good.
Yes.
Okay, so you need to know support and then assign to view, which means all the support check will be deleted. Okay, now you understood now support. Now you know the concept of support. Only thing, whenever like application will change, okay, that you can able to get from which kind of structure and what is going to happen on it, and then you can come to a conclusion which support you want. Okay,